Graphing absolute value functions. So we're going to talk about what the parent graph of an absolute value function looks like first, and I have it graphed over here. It is a V-shaped graph, and the vertex, the corner point, is at 0, 0. And that's an important point we're going to touch on in a little bit. But this is our parent graph, y equals the absolute value of x. There are certain characteristics that you're going to want to be familiar with, and it will make graphing easier. This model that I'm circling in blue, y equals a times the absolute value of x minus h plus k. That's something you're going to want to remember and write down. First, to find the vertex, you need h and you need k. Our point comes from those two numbers. So h, comma, k is our vertex. But the one thing you want to remember is that h is going to be opposite. So if the equation says x minus 3 inside the bars, it's going to be a positive 3 when you plot it. Looking at our example, notice we have no h inside with the x, and we have no k at the end. So that's where our vertex of 0, 0 comes from. We're also going to talk about how and what direction the graph will open. And to get that, we look at the letter A, the number in front of the bars. If A is a positive number, the graph will open up. If A is a negative number, the graph will open down. Looking at our parent graph, we don't see a number in the front, so it's going to be a 1. It's a positive 1, so it opens up. Width also comes from the letter A, and that's if A is greater than 1, you're going to have a skinnier graph. And if A is less than 1, so if it's a fraction, you're going to have a flatter graph. These are also examples of stretch and compression when we talked about transformations. So let's look at an example. So y equals the absolute value of x plus 2. First it's asking what transformation occurred. From here, I'm going to circle my parent graph. So I have y equals the absolute value of x. And at the end, I have this plus 2. Anything at the end, that is a vertical transformation. So this graph went up 2. So I am next going to look for my vertex. And remember, our vertex was h, comma, k. H is the number on the inside. So inside with x, I don't have a number. So it is 0, comma, k is at the end. That's where I'm getting 2. So 0, 2 is my turning point. Now I already have this graphed here, and I'm going to show you how I did it. If you look at the top, I have the website for your graphing calculator. So you're going to want to open up a new tab and make sure to pause the video because I'm going to keep going. So I'm going to go ahead and take us there. All right, in order to use Desmos, and this is our new graphing calculator, we're going to type in y equals, and to get the absolute value, in the bottom left corner of your screen, you'll see a keypad, and you're going to want to click on that. And a bunch of options will pop up. And I know on my screen you can't see them all. But after you get all the buttons to pop up, if you look down below the X, underneath the parenthesis, you'll see the absolute value sign. So we're going to click that button, and my bars pop up. And then we can just finish typing everything in. So X, and then arrow over, because we want the plus 2 at the end. And you can see we have our V-shaped graph, and it gives us our vertex of 0, 2. You can zoom out or zoom in. If you click and drag, you can also get other points on the graph. And they do show up with decimals, but you can see that you do have real numbers too. If you don't want to find your other points that way, you can hit this wheel and then click on the table, and the table will pop up with points that you can also plot. So those are just some ways that you can play around with Desmos and how to transfer it from Desmos to your paper with the graph. I'm going to switch back to the notes. Okay, so I have the graph graphed. I have my vertex at 0, 2. And now I am going to talk about the domain and range. Okay, as a reminder, domain are my x values, range are my y values. So first let's talk about domain, all of the possible x values. Now remember, if I keep going to the left, negative infinity is all the way to the left, and all the way to the right is positive infinity. So I'm asking, domain is asking, how far left and how far right does this graph go? So it's going to go all the way to the left because of our arrow, and it's going to go all the way to the right because of the arrow. So there's no stopping, which means it's going to go negative infinity, comma, positive infinity. And we're going to use our parentheses to close it out because we can't touch infinity. Make sure the smaller number is always listed first. Range is our y values. So the farthest down this graph can go would be negative infinity, and the farthest up this graph could go would be positive infinity. So now, how far down does this graph go? Well, this stops at our vertex, which is at the point 0, 2. But remember, range, all we care about are the y values. So the smallest, the farthest down this graph will go is 2. And the farthest up this will go, because of the arrows, it's going to keep going to infinity. Now 2 is an actual number, so it gets a bracket. Infinity gets a parenthesis. All right, now let's talk about let's talk about increasing and decreasing. That part gets a little tricky. I'm going to pull up the star here. Hopefully that'll help. Okay. Whenever we're talking about increasing and decreasing, we always start on the left side, and we only care about the x values. So I'm going to put the star on the left. And because of that arrow, we're really starting at negative infinity. So if the star was on a roller coaster, and it was going to ride the graph, so it starts at my arrow, this is going down, so it is decreasing. So it decreased from my arrow, which was negative infinity. So on my decreasing side, I'm going to say negative infinity, comma, and it stopped decreasing at my vertex. And again, all we care about are the x values. So it stopped decreasing at 0. Both of these are actually going to get a parenthesis because even though 0 is a number, at this point, the star is not increasing or decreasing. It's flat. Okay, so now the star is at 0. To go on the other side, it's going up the graph. So it's up the roller coaster. So it is increasing from 0 to the other side of the graph, which is positive infinity. And I know increasing and decreasing, that is tough to get at first, but we're going to keep practicing with it. All right, and then finally, end behavior. And all end behavior is asking, which way are the arrows pointing? So in this case, both of my arrows are pointing up. So that means my graph is going towards positive infinity on both sides. And that is our first example. All right, let's go to another example. So now I'm going to go back to Desmos. I'm going to clear everything out. Okay. And then sorry, back to the notes. Here's our next problem. Y equals absolute value of x plus 3. First, let's talk about our transformation. So if I circle my parent graph, y equals the absolute value of x. I have this plus 3 inside. That means it's a horizontal shift, so it's left and right. Since it's a plus 3, this graph is really going to the left 3. Okay, now I'm going to jump back to Desmos. I'm going to type it in. So again, y equals absolute value button, and then we're having x plus 3 on the inside. And here you can see we have 2 gray dots. So it gives us 2 points that we could possibly plot. If you need more or want more, hit the wheel, hit the table, and you get a whole bunch of other ones that you can plot. All right, so I'm going to jump back to the notes. I'm going to actually plot this one now. Okay, so we have our vertex, which was -3, 0. And just a reminder here, remember h comma k. H is +3, but we take the opposite. So it's -3, comma, no number at the end, 0. So that's also where I'm getting this vertex. Then we make sure it's a V-shaped graph. All right. Oops, sorry. Back to my lines. And then I'm going to change those to blue in 1 second, guys. Just so we don't get confused. There we go. All right, and there's my graph. All right, next up is to talk about domain and range. Remember, domain are my x values, range are my y values. So the farthest, the smallest x value, the farthest left is -infinity. Farthest right is +infinity. So this graph is always going to go to the left. It's always going to go to the right. So my domain is -infinity to +infinity, both with parentheses. Range, the farthest down this will go is -infinity. The highest up it will go is +infinity. So for my blue graph, the farthest down it goes is actually at the vertex, which remember was -3, 0. The y value of that vertex is 0. And the farthest up this graph will go, because of my arrows, is infinity. 0 gets a bracket, infinity gets a parenthesis. And then we have increasing and decreasing to talk about. So let me pull up the star again. All right, so again, increasing and decreasing, we only care about the x values. So we're going to start, oops, sorry. We're going to start on the farthest left, which is this arrow, meaning -infinity. So from -infinity, I'm going to go down, so I'm decreasing to my vertex. The x value is -3. So I'm decreasing from -infinity to -3. Both are getting parentheses. And then from -3 to the other side, I am increasing. So I can say I'm increasing from -3 to +infinity. And then finally, in behavior is asking which way is the graph pointing? What way are my arrows pointing at the end? And they are both pointing up, which represents +infinity. All right, so we got 2 more like this. So this next one, it's a negative. All right, so again, first I'm going to do my transformation, and I've got y equals, and then the absolute value of x, which leaves me with this negative in the front. And think back to transformations, that was our reflection, or our flip, over the x-axis. Now I'm going to let you guys pause the video and try to graph this on your own using Desmos. So go ahead and do that. All right, and I'm going to go ahead and graph this as well. And we should get a V-shape graph, and it is pointing down. And we knew this was going to point down because of the negative sign in the front. Remember when we first talked about this, if it is negative in the front, our graph will be pointing down. He'll be opening down. Okay, so now let's talk about domain and range. Again, domain is x, range is y. Smallest x value is all the way to the left, which is negative infinity. And positive infinity is all the way to the right. All right, so now from negative infinity to positive infinity, my graph is going to go all the way to the left, and it's going to go all the way to the right. So that is my domain. Negative infinity, positive infinity, with the parentheses. Range is up and down. So the farthest down this will go is negative infinity. The farthest up this will go is positive infinity. All right. So now the farthest down this graph does actually go, it's pointing down, so it's going to keep going down forever, which means negative infinity is the smallest y value. And the farthest up this goes is again our vertex, which is at 0, 0. The y value of our vertex is 0. So negative infinity gets the parenthesis, 0 gets a bracket. All right, then we have increasing and decreasing. So remember, we're starting on the left, and all we care about are the x values. So the farthest left was negative infinity. So from negative infinity, I'm going to go up. I'm actually increasing first. So I'm increasing to my vertex where I have an x value of 0. So I am increasing from negative infinity to 0, which means then I'm going to decrease from 0 to positive infinity. Remember, all we care about are the x values. We are on the positive x side. So 0 to positive infinity. And then finally our end behavior. End behavior is asking which direction are my arrows pointing. So when x is in the positive infinity range, my graph is pointing down. When x is at the negative infinity, I'm pointing down. So both of these get negative infinity. All right. So we got one more like the graphs. So now we have y equals 3 times the absolute value of x. So this one I actually want you to try on your own. So go ahead, pause the video, try filling everything in, and then check back in a little bit for the answers. Okay, here are all the answers in the graph for this problem. So the transformation was a stretch by 3 because if we look at our parent graph, y equals the absolute value of x, the only thing we have is a 3 in front. And since it is bigger than 1, it is a stretch, and it's stretched by 3. Then I went to Desmos and I got my points, and I graphed, and I knew it was going to be a skinnier graph because of the stretch. I also know that my vertex is 0, 0 because of the h and k. Domain, I said negative infinity to positive infinity because this graph's going to go all the way to the left and all the way to the right. Range is 0 to infinity because the farthest down it goes is 0, and it will keep going up forever, which is infinity. Now, increasing and decreasing, I'm going to go through with the star. So we start on the left, which was our negative infinity, and we decrease to our vertex, which was at 0. And then we increase from 0 to the other arrow, which was positive infinity. And then finally, in behavior, which way are our arrows pointing at the end? Both are pointing up, So both get positive infinity. All right, these are the last two we're going to talk about, and they're going backwards now. So you're given a graph, and you have to write the equation. Up here I have that model that we need to work from, and this is something you're going to want to write down and remember. Okay, so the most important thing to find first is our vertex. So in our first example, we have our vertex, and it is at 1, 2, 3, 1. So since we have our vertex, we also have h and we have k. So if I go to fill in this shell, it is y equals absolute value of x. I'm going to leave some space and then fill in the rest. So h is a positive 3 on the graph, which means inside it's minus 3. K is a positive 1 on the graph, which means at the end it is plus 1. Now the only thing that we're missing is the a. And think back to Algebra 1. To get this, you just have to count the slope. So if we start on the vertex, and if I go to the next point I see, I go up 2, and then over 1, which is my rise over run. If I simplify this, 2 over 1, that reduces to 2. So there's my a value, 2. And that's it. So if you want to try the next one on your own, go ahead and pause. If not, I am going to go through this one as well. So first step is to find the vertex, which is my corner, and that's at -1, -2, -3, up 2. So -3, comma 2. And that is my h and my k. So I'm going to make my shell now. So we have y equals absolute value of x, leaving some space. Now, filling in my h is -3 on the graph, which means it's going to be plus 3 inside the bars. H is always opposite. My k is 2, and it's a positive 2 on the graph, which means it's a positive 2 in the equation. Now, one thing about this graph is I notice it's pointing down. So I know there's going to be a negative number. But negative what? So again, I'm going to count my slope. And let me go to the next point. So it looks like I went down 1, over 1. So -1 over 1. That reduces to just -1. Which, if you want, we already have the negative sign. If you want to write the number 1, you can, but you normally won't see that written. You'll just see a negative sign. And that's it. That's how you're going to write the equations as well. So I know the graphing was a lot of information, and hopefully you took your time in watching the video. If you have questions, again, feel free to reach out to me, email, or come see me at Bulldog Block.